Next, here continuation. Now, since those three lines are mutually perpendicular to each other, that means the angle between the lines is 90 degrees. That means L1 L2 plus M1 M2 plus N1 N2 is equal to 0. That's why direction ratios of the given line are 1 to 1. Direction ratios of our third line are LMN. That's why L1 into L2 M plus M1 into M2 plus N1 into N2 is equal to 0. Again, we are eliminating N, R, M, R, L from these two equations. Here I am eliminating N. That means N is equal to minus of L plus 2M. Substituting in the equation number 4. Once again, which is a quadratic equation in L or M. You can. Now here I am trying to find the factors of this one. I got two factors. 3L plus 2M into 2L plus 11M is equal to 0. Right? 3L plus 2M is equal to 0, 3L is equal to minus 2M, or 2M is equal to minus 3L. Here L is equal to minus 2 by 3M, or M is equal to minus 3 by 2L. Substitute L value is equal to minus 2 by 3M in equation number 5. We will get M value in terms of N. Right? Similarly, here M in terms of M is equal to minus 3 by 2L. From here, the same M is equal to minus 3N by 2. Therefore, M is equal to minus 3 by 2L is equal to minus 3M by 4. Right? Now, we are writing in a proper order and throughout dividing by minus 3 or 3. M by 3 is equal to L by minus 2 is equal to N by minus 4. L by minus 2 is equal, we are writing in a proper order. L by minus 2 is equal to M by 3 is equal to N by minus 4. Throughout we are multiplying by minus sign. L by 2 is equal to M by minus 3 is equal to N by 4. We call that equation number 6. Similarly, 2L plus 11M is equal to 0. Here 2L is equal to minus 11M. L is equal to minus 11 by 2M. Or M is equal to minus 2L by 11. Substituting L value minus 11M by 2 in equation number 5, we got M in terms of N. M in terms of N. Here M is equal to minus 2L by 11. From here, the same M is equal to 2N by 7. Right? Therefore, M is equal to minus 2L by 11 is equal to 2N by 7. Throughout we are dividing by 2 this one. M by 2 is equal to L by minus 11 is equal to N by 7. We are writing in a proper order. L by minus 11 is equal to M by 2 is equal to N by 7. From these two equations, we got the equations of those two lines, those mutually perpendicular generators. One line is x by 2, y by minus 3, z by 4. Another line is by taking these direction cosines, x by minus 11, y by 2, z by 7. These two are the two mutually perpendicular generators of the given cone. Same procedure, right? Next one, find the angle between the lines given by here x plus y plus z is equal to 0 and a cone is given, right? This is a first degree equation in xyz. A first degree equation in xyz always represents a plane. This is a plane. Now this is a cone. Now given plane is this one, given cone is this one. Consider 1 by a plus 1 by b plus 1 by c. Why we are considering this one? Here where a is the coefficient of yz, b is the coefficient of zx, c is the coefficient of xy, right? Right. Now see here, just I am considering the coefficients. I am adding 1 by, what is the coefficient of yz? 1 by bc. Coefficient of zx is 1 by ca. Coefficient of xy is 1 by ab, a minus b. That means I am substituting this value is equal to 0. That's why I got 1 by a plus 1 by b plus 1 by c is equal to 0. If this condition is satisfied, then the angle between the lines is equal to pi by 3, that is 60 degrees. You have to remember this one. If the coefficient of a, coefficient of yz, coefficient of zx plus coefficient of xy, right? If you consider that one, 1 by, see this is a formula you have to remember, it's a shortcut formula, 1 by coefficient of yz plus 1 by coefficient of zx 1 by coefficient of xy. If the value is equal to 0, then the angle between them is always equal to pi by 3 only, right? Otherwise, we have to find the lines. So same as by previous procedure, let one of the lines be x by l is equal to y by m is equal to z by n, right? By substituting those l x value, y value and z value in those two equations, and by eliminating l or m or n, you will get the two lines. From those two lines, you can find the angle between them by applying the formula cos theta is equal to L1 L2 plus M1 M2 plus N1 N2 by square root of sigma L1 square into square root of sigma L2 square. That is a lengthy procedure, but you should remember this shortcut one. Next, fourth one, if a plane 2x minus y plus cz is equal to 0 cuts the cone yz plus zx plus xy is equal to 0 in perpendicular lines, find the value of c. Now, given plane, given cone we wrote, condition that the plane cuts the cone, this is a formula, right? Should remember this one. Cuts the cone, here the second at 90 degrees is, this is the condition, a plus b plus c into u square plus v square plus w square minus f of u comma v comma w is equal to 0. Now by comparing this equation with the standard form of the cone, we got the value of a, b, c, u, v, w, right? And also we need those values now, that's why we wrote all those values. Substituting in this formula f of 2 comma minus 1 comma c, because u value is equal to 2, v value is equal to minus 1, w value is equal to c from here, right? Now by simplifying this one, we got the value c is equal to 2. This formula is already there, right? See here, if the theta is equal to 90 degrees, then tan theta is equal to infinity, that is a plus b plus c into u square plus v square plus w square minus f of u comma v comma w is equal to 0. This is an important one, right? Now continuation, fifth problem, find the equation of the lines in which the plane cuts the cone, right? Again same procedure. First of all, we are writing the given plane, given cone equation. We don't know the line equation. Let the line equation be x by l is equal to y by m is equal to z by n. Now substitute this line this means this line lies on the cone, that means it satisfies the cone equation. That's why we are substituting x is equal to l, y is equal to m, z is equal to n in cone equation. We got this result, and this line is perpendicular to the mutually perpendicular generators. Therefore here this line is also common to the plane. That's why we got u2l plus m minus n is equal to 0. We are substituting x, y and z values in the plane equation. We got this result. Now from equations 4 and 5, we are eliminating either L or M or N. Here I am eliminating N value. That means I am finding N value from equation 4 and then substituting in equation number 5. Now I got this relation. Again, by simplifying this one, I got two factors. 4L minus 4L is equal to M, or L is equal to minus M by 4. Similarly, from the second factor, 2L plus M is equal to 0. This is M is equal to minus 2L, or L is equal to minus M by 2. Now, from equation 4, substituting those values, 2L plus minus 4L minus M, minus 2L minus M is equal to 0, 2N is equal to minus 2L, or L is equal to minus N by 2. Here L is equal to minus N by 2. Here the same L value is equal to minus M by 4. Therefore L is equal to minus M by 4. The same value is equal to minus N by 2. We are writing in a proper order. L by 1 is equal to M by minus 4 is equal to N by minus 2. Or dividing by minus sign, we got this result. We call that equation number 6. Next, from the second factor, we got 2l plus m value is minus 2l, no? Minus n is equal to 0. 2l gets cancelled, n is equal to 0. Here we are writing n is equal to 0 into l we are writing, or l is equal to n by 0. This is important concept. Now L is equal to n by 0 and the same L is equal to minus m by 2. Right, therefore L is equal to minus m by 2 is equal to n by 0. We are writing in a proper order, that means L m n. L by 1 is equal to m by minus 2 is equal to n by 0. We call that equation number 7. From these two equations, the line equations are simply replace L m n by x y z. X by 1 y, x by minus 1, y by minus 4, z by 2, and x by 1, y by minus 2, z by 0. Or if you multiply throughout by minus sign, you will get x by minus 1 is equal to y by 2 is equal to z by 0. Next problem, if x by 1 is equal to y by 1 is equal to z by 2 be one of the set of three mutually perpendicular generators, right, of the cone, find the equations of other two generators. Same as previous procedure. We are writing the equation of one of the generator, given cone, right? We don't know other two generators. Let one equation be x by L is equal to y by M is equal to z by N. Now those three mutually perpendicular generators, no, that means this is mutually perpendicular to this line and this is the generator of the cone. That's why this line lies on this cone, right? Now that means it satisfies this equation. Now since equation 1 is perpendicular to equation 3, that means L1 L2 plus M1 M2 plus N1 N2 is equal to 0. If two lines are perpendicular to each other, that is the condition. A1 A2 plus B1 B2 plus C1 C2 is equal to 0, or L1 L2 plus M1 M2 plus N1 N2 is equal to 0. And this is equation 3 is a generator of the cone, therefore it lies on the cone, it satisfies the equation of the cone. We got two conditions, those are equation 4 and 5. Again, by eliminating either L or M or N from the equations 4 and 5, we will get the relations as case of previous problem. See, two factors we got. Now we are expressing m in terms of n or n in terms of n, and the second factor also n in terms of m or m in terms of n. We are substituting in equation 4. We got the result like this: L by 2 is equal to m by minus 4 is equal to n by 1. By using the second factor, I got this result: L by 3 is equal to m by 1 is equal to n by minus 2. Here throughout dividing by minus 2 or 2, right? Now from equation 6 and 7, the other two mutually perpendicular generators are simply replace L m n by x y z. X by 2 is equal to y by minus 4 is equal to z by 1. Here x by 3 is equal to y by 1 is equal to z by minus 2. These are the other two mutually perpendicular generators of the given cone. Same problems, same procedure. We have to assume, let the line be x by L is equal to y by M is equal to z by N. Substitute those values in the given equations, and the given equations you got two conditions 4 and 5. Solve the equations 4 and 5, you will get the line equations.